let's move. I'd like to really talk real quick about this post-assessment and explain how I'm going to grade it. If you open, you're going to have an extra credit now for your progress report cards. But if you complete and have a grade that's on grade level or beyond grade level, that means greater than 75%, I will give you 100%. But I'm not going to give you 100% in only one test. I give you 100% in all the testing. All the tests that we have for the fourth quarter, you're going to have 100%. Okay? You don't need to take any more tests this quarter, as long as you have on grade level or beyond grade level on this assessment. It's more 75% or more. Yesterday we worked on some radioactive stuff. Remember? Because we have so many applications of exponential functions, and one of the applications is about radioactive material. We can calculate how much radioactive material is left after a period of time. And this is how we do. We have the function. It's going to be an exponential function, and we will have the time. We just need to plug in the time, the value of the time, into the function. Remember, we worked on this example yesterday. Actually, yesterday we worked example A. Now I'm showing here example B. The solution is you substitute t equals, in this case, 3,240 years. You're going to substitute into the function, and then you will find the exponent, the result for the exponent. But it's missing. The number is missing. I need you to help me. From the previous step, you can calculate, you can find out what is this exponent. Or you can also find out by the result, because 1/2 exponent something, this is missing, equals to 0.25 grams. I need your help to find the answer. I need you to tell me what is the number missing. This is an application of exponential functions, as we have seen, and we could calculate the number that's missing by checking the fraction. 3,240 divided by 1,620, and this is equals to 2. 2 is the right answer. Let's then move on, because today we have something that we actually worked on something like that before, and we will work a little bit more, try to understand a little bit better, okay? How to solve exponential equations. If you have two equations, you have an exponential equation, and on both sides of the equation, we're going to have an equality, right? You have an equality, but let's say if you have on both sides the same base, the same number as the base, and the exponents are going to be kind of different expressions. The same base b, exponent x, equals to the same base b, exponent y, okay? You can say, by looking at this, you can say that x needs to be equals to y to make this equation true. So x needs to be equals to y, as long as if you have the same base, okay? And the base can be a number, like 2, 3, 5, as long as they are the same, you can say, yes, for this to be equal, we need for x to be equals to y. Make sense? Now let's apply this idea, this property to an example. we have an example here. 4 exponent 2x minus 9 equals 64. But wait a minute, we don't have the same base. We need to have the same base, right? To compare the exponents. And here we don't have the same base. But maybe we can try to represent 64 using the base 4. If you're not sure, bring your calculator and let's try, okay? 64. 4 times 4 times is 16 times 4 again is 64. So we multiplied 4, 1, 2, 3, 4 times 4 times 4, 4 exponent 3. See? Now we can compare the exponents because 2x minus 9 needs to be equals to 3. X minus 9 equals 3. And you're going to simplify, apply addition property of equality. Move this to the other side, becomes a positive 9. Then you have 2x equals 3 plus 9, 12. And now you're going to divide both sides of this equation by 2. And then you have x equals 6. That's going to be the right answer. Okay, questions? Any questions? What do you think? Makes sense? Do you think you can repeat this step by step on the questions that we have on the quiz? We kind of all the questions on the quiz, you're going to be able to use this procedure. I just need you to make sure that you understand this step by step, and then we will move on. We're going to try to apply on the quiz. You all agree? If you have a question in your mind, send me now, ask now. But if you agree, we will move. We're going to practice on the quiz. Do you agree? Yes? No? Maybe? So we are checking. We check that 1 is not a good solution because 1 equals 2. No, this is not right. We check that 4 squared is equals to 2 exponent 4, 16 equals 16. Right. So 4 is a good solution. 4 is a very good solution. I told you this have at least three solutions. We can check, one way of checking it is by graphing. Have a look, I've done this before. I type it here on the first line 2 exponent x. I type it on the second line x squared, and then we have the graphs here. We will find 3 intersections. One intersection is for x equals 4. Another intersection is for x equals 2. And we have a third intersection, x equals negative 0.76666, and a bunch of decimal places. So this is also another solution. It's hard to calculate, but we can look, you can find it on the graph. Today on the quiz we have to solve the exponential equations by using the property b exponent x equals b exponent y. We will try to make both sides of the equation to have the same base. Okay? So let me get my... On letter A, an example is letter A. We have a 5 exponent x equals, and we need to represent 625 using base 5. And 625, we can use the calculator. If you're not sure, you can get the help from your calculator. Okay, so 5 times 5 is 25. Oops. Times 5 again is equals, oops, sorry, 5 times 5 times 5 times 5 equals 625. So 1, 2, 3, 4. 5 exponent 4. We can say 5 exponent x equals 5 exponent 4. Now you compare the exponents, and you can definitely say that x equals 4. This is a good answer. Okay? Okay, Alexis, no problem. And that's what we're going to do today. Make both sides of the equation to have the same base, and then we compare the exponents. Okay? For letter B, let me choose another color. Check this out. We have 3 exponent x equals, we need to try to represent 243 using base 3. If you're not sure, you can always bring your calculator and try this. 3 times 3 times 3 times 3 again times 3 again. 243. How many 3's we have? 1, 2, 3, 4, 5. So 5 3's. That means 243 is 3 exponent 5. So 3 exponent x equals 3 exponent 5. X equals 5. Okay? Letter B. Thank you, Kalia.